Hi there, so it's our final data collection lesson. This one is just based on practicing the skills we've already learnt, which makes it in many ways not less important but more important, because any time you want to review the skills before an exam or something, maybe in a year's time or so, or a month or whenever, this is probably the video to go to and go through those, because it'll cover all the things in one go. As long as you've understood the basics of all the other stuff, then this is the one to have a little look at. Okay, well, let's get started. Right, well, I would recommend that you pause the video and have a go at the whole of this question before then unpausing it and just seeing how you got on compared to what I reckon. So first of all, the opportunity sample of the first 5 dates, that's the easiest way to take it, isn't it? Should give you 14.6 plus 8.8, add 7.2, add 7.3, add 10.1, all divided by 5, which should have given you 9.6 millimeters. Next part, when it says describe how you would use the random number function on your calculator, it doesn't mean you have to describe how your particular calculator works, more how random sampling works. So you need to be telling them that you need a sampling frame. Now there's already one there if you want to use that, which can save you some words. So I would say use the dates as a sampling frame, and then select the temperatures for the first 5 different numbers generated by the calculator. Something like that. Next up, using the simple random sample to collect your 5 dates. Well, you just need to have picked out 5 of these. You don't have to show exactly how you did it, but I will show you now how to do it with the Casio FXCG 50, because all of these things can take you time to get your way around. So the first thing you want is option, so press option. Then we want probability, so I go on the arrow across to probability, and then rand stands for random, so I press F4 because it's under random. Then that will be any random number, but you'll get decimals. We want whole numbers, so I'm going to go for int, which stands for integer. And then I want numbers from 1 to 15, so if we go 1, 15, close brackets, and press equals, that gives me 14. So I'm going to select 10.0, press equals again, another 14, ignore that, 15, 9.5, 13, oh, this isn't coming out too much like you'd expect a random one, would you? Is it? 15 again, ignore that, 8. I've done this before, I've never had the numbers all that close together, but randomness, these things can happen. And 1. So actually I've ended up with a load of ones which are actually quite close together, so whether or not that's going to give me something that different to that, I'm not sure. So I'll put all of those in there and divide by 5. And that's given me 11.02. Now you'll have different values, and it doesn't matter what they are, but it's important that you do write them down to show that you've done it, whichever ones it is that you've ended up with. Right, so next up it wants all 15 dates, which just means chucking them all in there. So that gives us 10.8 millimeters. You should have got 10.813, but we leave things to 3 significant figures unless otherwise told. 10.8 millimeters. Comment on the reliability of your 2 samples. All we need to say there is that since the second one was random, it's more likely to be reliable than the other. But in this case, I would say, as random can, I've got lots of dates close together, so they're pretty similar in terms of how reliable they are. And actually, one of them's slightly higher and the other one is slightly lower than what we've got by a similar amount. So, yeah, not much more to say from that. And whatever you get, you just have to respond honestly to whatever that is. another quick one here for you to have a go at. One advantage and one disadvantage of stratified sampling and simple random sampling. When you're asked for two, you're kind of thinking of where one of them is an advantage over the other as well. So I've started off by saying that stratified sampling guarantees that the characteristics are representative of the population, but it can be time-consuming and expensive to group those characteristics. Simple random sampling is going to be quicker and easier, but it's going to have the danger of possibly creating bias by having too many of one characteristic together. So I've just gone with it. Random is quicker and cheaper, but may introduce bias if some characteristics are over, or I could have said underrepresented. Okay, here's another question for you to pause and have a go at before comparing to my answers. Right, so why is it likely, if you just ask people, that it's going to produce a biased sample? Because those on the shop floor won't be represented at all. And I've also said that, that they outnumber the office workers 2 to 1, so it's definitely going to be biased, isn't it? Okay, so in order to make a systematic sample, you're going to need a sampling frame, and then we're going to need to divide the total number of 300 by 30, and it should look something like this. So I've got my 300 clearly divided by 30 to get every tenth, produced a numbered list. You must write that down of all 300 workers. That's your sampling frame. Randomly select one of the first 10 because it's every 10, and then every 10th worker on the list after that. If you want to give an example like e.g. 5, then 15, 25, 35, then that's great too. Right, now stratified sampling, we need to have two separate lists of 100 and 200, and then take twice as many shop floor workers. Your answer should look something like this. So I've gone with, we've got 1/3 are office workers and 2/3 shop floor, create two numbered lists, then use a random number generator to select 10 from the office workers list and 20 from the shop floor. Anything that clearly shows something like that would be great. And finally, quota sampling would be a case of just asking the first 10 office workers and the first 20 shop floor workers that the managing director can find. And that should look something like that. Okay, just one more question to go. Here's an exam style question with some marks at the side to show you sort of how much. So they're all quite short questions. Pause the video, give it a go. Right, well it's not random because we have selected it's always the same time of the month. So two alternative sampling methods. Well, you could go with stratified, but it'll be simpler just to go with random sample and simple random and systematic, which should look something like. Mainly to bias if all of the things are too close together. So with systematic, I've said it makes sure that all the months are represented in the same way that we've got there, but it can introduce a pattern because the gaps are the same each time. And it's difficult to predict what that pattern would be, but it can do. Right, is the data discrete or continuous? It's continuous, but you do need a reason because it could take any, because measured things could take any value. Calculating the mean of the 6 data values given above just means adding them all up and dividing by 6, which should give you 8.2 millimeters to, well, I know I said it should be 3 significant figures, so if you've got 8.17, that's absolutely fine. But they do like it with the data set to say that you should give it at whatever accuracy the data's been given at. So that's the one reason why I'd go for that. So it's all of these added up, divided by 6. And finally, the reliability of this value as an estimate for the mean total rainfall in Beijing during 2015. And I would say it's not very reliable because this is all of the summer in Beijing. So you've got none of the winter months. You've just got half of the year. It's the warmest half of the year. So the winter is not represented at all. Also, you could go for the fact that August has got this massive thing. What's going on there? Not sure what happens in terms of, is that a monsoon thing? I don't know. But go for anything sensible will be okay. But the safest one is that you've got only 6 things. I'm not going to bother writing that down. And that is that for now. So I hope that all helps. Goodbye, folks.